Hi, welcome to the lab. So we are building a scanner generator library, and in last time we worked on this project, we left it in quite a mess. And yeah, well, I'm going to clean up today, basically. So let's have a look. What did we actually do? So I think in our main class, yeah, so the last time we worked on turning our scanner into a big table, basically, into a big transition table, which you then can bake into your program, so that when you want to use your scanner, you don't have to include the specification for your parser. So for your scanner, of course, not your parser. So yeah, as I said before, that I like to specify tokens in such a declarative style while I'm developing a language or a tool which has to parse things. But of course, you probably don't want to include the specification in your released product, since, yeah, basically you don't have to do those kinds of operations. So every time this program runs, for each of those tokens, a non-deterministic finite automaton is created, and of course you don't want to waste your customer's time or the consumer of your library's time to create automatons out of your specifications, which then get combined into a single automaton, and then they are further processed. And yeah, so you don't want to waste your let's say your library consumer's life, and so you might want to only release a big table which they can just include in their project, and yeah, basically you are where you are done. So this we did this the last time, and today, yeah, I would like to clean this up. So we generate this expression, but this and this array are inlined. So let's just run our program. So if I run this now, well, let's wait until it terminates. So it's currently running, scanning a huge file, a 32 megabyte file, and it just measures how long it takes. Yeah, so get this expression, which is basically this expression, but with the states inlined. But this doesn't really work. So yeah, so I can't generate this into a single expression. And yeah, basically I would like to try, since I know that there's a extension, a GCC extension, which allows me to write statements in expressions. And then I would like to try if this is possible to include here. So let's just this one. So I think it works. Oh, but why does it cry? A semicolon. Okay, this is a table. So I think it is possible to create a single expression. So let's do this. Let's try it out. So the static table. So basically we have a little class which represents the transition table, and the information, basically the information that is required to run our scanner without the automaton. And we have the toString function, the format function of the static table, prints this expression. So, and Oh, and here we generate the static table. So what did we have to do? We have to wrap it in open parentheses, open curly braces, and at the end, closing, closing. Now I think I can just put this here. So first the two states, so the start state and the error state, which is fine. No, I have to define this first now. So let's split the print. And here, like this for now. Now what did we have to do then? Just the declaration. Okay. So let's steal some code. Yeah. So these states. So this is the transitions. Don't know why I call it states in our main, but doesn't really matter. So and here I first put the transitions, then the positions like this. I think I have to overthink how this is done. So let's rename this to format. So basically now I don't want to generate the list view as one big expression, but I have to split it. So basically, so the elements are not printed, not part of list view printout anymore. They are printed separately. So maybe I will just do the following. Let's call this one format array. And so I can provide the data as a list view still. Yeah, let's do this instead. So, and I don't need the name anymore, the type anymore. I'm just going to steal this code, just steal everything and then just adjust it. So open parentheses, open curly braces, I mean, like this, and then the elements as before. I think I can now remove this method, and now just going to format array. So I don't need to pass in element type anymore. Just going to format the elements. Hey, I don't need this one. Let's call this format array literal. I think the name is a little bit clearer, more clear. Literal. Format array literal. Okay, so now this should be fine. Now let's print the semicolon. So now I have the transition table. Now let's do the accepting table. So formatting, format into. For the type, element type is sigil, basically this, the token type. Let's call this one accepting. And then format array literal, and of course the accepting table. And then the semicolon. So now to format let's reintroduce the method that we had previously. Let's call this format list view. But it doesn't get the data inline. So basically I'm passing in the view, but also the the name of the member which contains the data. So data member, let's call it this way. So, and to print a list view, now that we get the member separately, you're just printing core list view. So let's also the element type. Let's also give it the element type. So like this. And now I give it the data member. So data member and then the count. So view dot size, then the closing parentheses. I think this should be it. So let's see what this does. So we first print list view, then the element type, and then in parentheses data member followed by the size. So in list view accepts it in this order. So first the data member and then the size. So and now to print a static table, I don't need to print this here. So first the two declarations, then I'm printing the prefix. So static table, the start state, open it next to our code. So the start state, error state, then the transition table, so comma, and the transition table. So here we format the list view, we pass it the data member of our transition. So transition. So let's put this one into a variable. So let's call it transition table data member. And also comma, paste. So then we format this list view by providing it the data member and the element type. The element type is sigil state and view, I think. Give it. So what is the view? The view should be position. But I think I don't need this, the count anymore. So the count, I think I don't need this, since I have a member here, which is basically an array, a static array. So I don't have to explicitly count the elements and bake in the count, but I can. So how does it work in C? So if I have a static array, let's say, or like this, I think I can size of ASD divided by size of ASD of 0, and this should give me the count of elements, shouldn't it? So let's include this in our expression. So of course, instead of ASD, we have to print the data member, so the name of the array. Here, the name of the array again, so like this. I think this should be it. And of course, I can remove this code. And do this. So perfect. So now give it the name of the static array and the element type. So now I would like to swap those. I like this ordering better. First the type, then the name. Doesn't really matter, but I would like to do this. So now we have the state array, then a comma, then the token type name, the token type array, and this name going to put also into a variable. So let's call this, well, accepting, and let's also just print it in between here. So now give it the accepting. So this should now create a single expression containing our static table using a GCC extension, of course. So I think this expression statement, so this, of course, is a GCC extension, but well, I'm not afraid of using one. So let's actually print this, and let's remove our code in our main. Let's copy this, just paste it in and see what happens. Paste, semicolon. I'm missing some spaces, but let's form it and look what it actually generated. So I think, except from a missing space, this looks okay, I guess. And I need a semicolon at the end. So let's keep this open. So let's see, where do I print this expression? So size of, print this here. So between the member and the size of, I need a comma. So I would put a comma here and here. Would basically work, except now I'm missing a semicolon at the end. So the static table, so here I'm missing a semicolon. So let's rerun and repaste. But let's first of all try it out manually. I think this works. So this mess expression returns a single static table which contains everything we need. And of course, this is just a hacky way. I'm not planning to actually do this way, but just to get going and just create this temporarily. So can I do this inline? Could be possible since it's now it's only a single expression. So seems like it works. Let's rerun. Seems okay. Okay, cool. This worked. So this way you can automatically manually create a scanner driver which is table driven, which doesn't need a DFA anymore. So, but of course, later I would prefer to have a small tool which I'm just going to feed in my specification like this one, and it spits out a class that I just have to include in my project. But I think this is enough for now. So since I would prefer to handcraft the scanner once my syntax is well, since as long as well, how do I say this? So I would prefer to craft the scanner by hand if the syntax isn't meant to change anymore. So this is just for language prototyping. I will use this grammar. So perfect. I like it a lot. So let's commit. So I made a little note here. So as I said, we left a total mess. We're going to commit this now. So what did we change? So let's start by committing this one first. So basically we introduced a new file which just contains the type alias for state and token type. And this is required since we factored out the static table into a separate class. So this class needed our type alias, which were previously defined our class scanner driver. So let's start by adding those changes. Yeah. Okay, so let's do this. I have to include the types here. Well, let's do this. I think I don't really need this, but I'm doing it anyway. So we introduced a new header, which is called types. And I'm just going to include this in our CMake. So I would like to commit this. So this one is related. So this is not related. Or is it? It is related. Maybe I have to commit this all together, since this already uses state. But I think the C++ file references the no, it's implemented inline, so it should be fine. So let's go through the changes. So I don't add this one. I can add this change and this change. Yeah, I'm just switching out the type. I'm also adding this change. This is the list view refactoring it separately. And this is everything what's new basically. So maybe I should have started with this refactoring with committing this, but doesn't really make any difference. So let's see. Vector type alias for digital state and digital token type. So this was the first change. Next, let's do the list refactoring. So basically, what did we do? We introduced a list view class, which is basically just a pointer to some data, and it has a size. And it's just a read-only view of a memory region, basically, with element type T. And it has a list-like interface. So yeah. So and then I refactored list to reuse a list view. So we have a method called toView on our list, and basically the iterator functions, they use the view internally. So I could remove this list iterator class, which I'm doing here. So this is okayish for now. Our list iterator is read only, and so we can share some code. So let's introduce this next. So introduce class core list view. This class a fixed size read only. Well, read only is not completely correct, since the access operator still provide the ability to write a fixed size view on some typed on a fixed size view on a memory region. Yeah, let's keep it as this. So what did we do next? We defined a static table, which is just the view on some memory which define a driver. And then we refactored our existing class and split it in two. Basically, one just works on a static view, and one which allocates memory and just. So let's look into our source code. The DFA table scanner driver. So let's start by looking at the static table scanner driver. So this class is basically the workhorse of the scanner driver, of the table-driven scanner drivers. It defines the operations. It implements the operations defined by our scanner driver interface. And so this just works on some memory which is provided by the constructor. And but this class is really dumb. So you just give it a static table and it just runs it basically. But the DFA table scanner driver has a little bit more to it. So this class can be used to turn an automaton a scanner driver, but internally it creates a static table to do so. So and this is currently the way to construct a static table. So you create an instance of this class using an automaton, and then you can use the member function the member method static table to get the table out of it. So this class just allocates the transition table and the accepting table basically, and has another instance which just get read-only views to this data, and well, this class is responsible for cleaning up the memory for those members. So basically, this is a table-driven scanner driver which you can use during development. And once you move to production, you switch out this class and just provide it a static table, and you just use this class instead and provided the static table which you can get from this class. So this is not the best API in the world, but it works for now. So, cool. Now let's commit this as a single commit. Why didn't it stage those changes? So split, how was it called? Sigil table scanner driver into two classes. Sigil DFA table scanner driver creates a provides a way we use a table-driven scanner driver provides a way to use a table-driven scanner driver, which is constructed using an deterministic automaton. The which is constructed using an automaton. So what do I actually want to say? Using okay, sigil static table scanner driver drops the need for an automaton. This scanner driver implementation requires a static table which can be obtained by calling then this method static table. Yeah, so this is just an overview which tries to explain the API, to give an overview over the API design here. So maybe I should say something like, so you can of course do what you want, but basically I would like to document that this meant for development, and this class is meant for production. Is meant for production if you choose if you first of all want to use a generated scanner, and second of all choose to use a table-driven scanner driver approach. So does it actually make sense what I've written? So let's read it again. Class DFA table scanner driver provides a way to use a table-driven scanner driver, which is constructed using an automaton. Well, okay. Class static table scanner driver drops the need for an automaton. This implementation requires a static table, which can be obtained by calling static table, the static table getter of this class. A table scanner driver is meant for development. Static table scanner driver is meant for production. You first of all want a generated scanner. Well, let's drop this enumeration and just continue with this sentence. Is meant for production if you choose to use a table-driven scanner driver approach. Okay, sure. So I think first part is more important. So of the documentation, of course. And I won't commit this horribleness. So let's see, what can we actually drop? So this to do put here. I will do this later, I think. Then I will, for now, drop this implementation. I don't need to print this anymore. I think I will keep this for now. I can remove this. So now our main program should still run. So where do I put this? So this just scans a file and measures the time. So I think I don't need to keep this. This was just for testing. And of course, then this won't compile anymore. I can just revert this to my old example, which is just starting the scanner REPL. So the interactive scanning, just remove some code here. Good. So now still work, should still work, but it should be a lot cleaner. So now I have my REPL again, and I can print out like 1 is less than 3. I don't support, yeah, so the less than operator is not included in my little example here. So that's why we're getting a scan error, an error token back, which doesn't point to the correct position. So let's actually count. But of course I won't count myself. The IDE can do this. So at character 6, so I'm looking here in this IDE the character in each line is 1 based. So I have to look at character 7. So this position we have a scan error, which is correct. So we don't support the less than. So this is perfect. So let's do 1 plus 3, since we should support plus. So, and this looks okayish. If white space, open parentheses, literal 1, white space plus white space 3, closing parentheses, then end of input. So perfect. It still works, and we are using a table-driven approach constructed using a DFA. So let's should I include this? I think I will just omit this and just include this as well. So I'm just going to commit it as is. I did not stage this change again. So clean up main.cp. So let's amend this change. Okay, so now I think we will stop here. So today we basically did a few cleanup steps and nothing too fancy, and basically to keep our main CPP a little bit more sane. And of course we worked on generating a single expression out of this static table print function. So this formatter now prints a single expression which you can just copy paste into C++, and then yeah, basically you get a instance of this class. Yeah, so the last time we left the project in little bit of a mess, and today we fix it. So this is basically all which I wanted to do today, or let's say in this video, and I thank you all for watching. See you next time. Bye.